All right. Good morning, CEC family and friends that are hopefully joining us as well. Thank you for joining us today. We're here to talk about an important topic to all of us, energy. It's something, again, that affects each and every one of us, regardless of what industry we may focus our work on. So with us today, we have Dave Spigelmyer, as well as Steve Winberg. I'll just give a little bit of information on each one of them. So Dave is currently the president of the Marcellus Shale Coalition. He has held that position for the last 7 years. And he's also, I should mention, a really good friend of CEC's. And we work with him a lot on a number of various things here in the Pennsylvania area. Prior to joining the MSC, Dave has worked for National Fuel Gas, Consolidated Natural Gas, Dominion, EQT, and Chesapeake. So long history in the gas industry.
A hard time holding a job.
And Steve Winberg is the Assistant Secretary for Fossil Fuel through the Department of, Fossil Energy through the Department of Energy. And Steve graduated from the State University of New York Maritime College, as well as the University of Pittsburgh. He began his career as an engineer at Foster Wheeler before joining Consolidated Natural Gas, Consol, and then the Battelle Memorial Institute. So with that, I will hand it off to these guys.
Thank you, Lauren. I'll get wired for sound here and then we'll get going. First of all, thanks to the CEC family for welcoming Steve and I this morning for a discussion on an important topic for every one of us, and that's energy. Ken Miller, thank you for allowing us to speak to your employees. Appreciate the leadership that CEC provides in the energy space. Certainly the professionalism of your firm is absolutely critical as we work to continue to advance natural gas development across not only the Commonwealth of Pennsylvania, but this entire region and energy across the country. I'm honored this morning to have with us Steve Winberg. Steve is the Assistant Secretary for Fossil Energy at the U.S. Department of Energy. Steve is from Pittsburgh, and he and I have had a nice history with one another for about a dozen years. Primarily during the 90s, Steve and I worked together at Consolidated Natural Gas and actually worked on electric and gas deregulation issues here in the Commonwealth of Pennsylvania and in Ohio. So we've had some history with one another. Steve, I'm going to begin by giving you an opportunity, first of all, to welcome the guests this morning as well and talk a little bit about the work of Department of Energy's Fossil Fuel Shop and what's the scope of the work that you do within fossil energy.
Okay, well, thank you, Dave, and CEC. Thank you so much for hosting me this morning.
Yeah.
And welcome to everyone that's watching virtually. So the Fossil Energy Office of the Department of Energy, we do research work across the fossil energy space. So in the coal space, we don't do a lot in coal mining, a little bit, some, but most of that work is in the end use. So long history of reducing criteria pollutants, the scrubber technologies, the selective catalytic reduction technologies, low NOx burners, mercury control, electrostatic precipitators, all of that got its start at the Department of Energy several decades ago. And now we're focused a lot on carbon capture, utilization, and storage. So that's the coal portfolio in R&D. We're also now looking at utilizing the carbon value of coal rather than the heating value to produce products. Some of them are high-end products like carbon fiber. Some of them are not so high-end, but it's alternatives for building materials, decking material, ceramic, a replacement for ceramic roof tile, using coal for wall board, things like that. So that's the coal space. In the oil and gas, we cut across the entire value chain from production to storage to pipelines, and even in end use, especially in the natural gas area. So things like advanced turbines, a lot of work in advanced materials that cuts across both coal, oil, and natural gas. And then the Office of Fossil Energy has responsibility for LNG import and export authorizations, although most of what we're doing these days is export authorization. And let me just tell you where we are on LNG exports. When I got to the department 3 years ago, we had about 2.5 billion cubic feet a day of export capacity. We're up to 9 billion cubic feet a day. Now, with COVID, it dropped off this past summer. We were down to about 4.5 BCF a day, but it's coming back up. The European market and the Asian market is recovering quite nicely. But 9 BCF a day of capacity. The end of this year, we'll have 10 BCF of capacity online, and there are 5 more Bs that are under construction that'll be up and operating here in the next several years. So basically a 50% increase in LNG export capacity in the United States from where we are today. What we have authorized is about 45 billion cubic feet per day. Will all of that get built? I don't know, because it's private capital, but what it does tell you is that there's a tremendous amount of headroom between 15 and 45. I'm not very good in math, but that's about 30 billion cubic feet that we can export to our friends and allies around the world. And I just think that is tremendously exciting because, as most of you probably know, before the shale boom or the shale revolution or unconventional oil and gas plays, however you want to describe it, we were a net importer. And now we are the world's largest producer of oil and natural gas. And that has taken place in arguably the last 15 years, and it's been done by private industry. Finally, we have responsibility for the Strategic Petroleum Reserve. When I came to DOE, people told me, my predecessors said, well, SPRO will just run on autopilot. You don't have to worry about it. And I got to tell you, that hasn't been the case. And here's why. The SPRO, the Strategic Petroleum Reserve, was set up back in the 70s because of the Arab oil embargo. Some of you are old enough to remember the long gasoline lines. So we built this crude oil reserve, 2 in Louisiana, 2 in Texas, about 750 million barrels. We have about 615 million barrels in the reserve right now. And Congress has been asking us to sell oil to help balance the budget, and so it's been declining. A funny thing happened with COVID. As we all know, demand destruction in gasoline, jet fuel, and distillate, or number 2 oil, just fell off the table, right? People quit flying, we all stayed home, gasoline consumption went way down. The refineries were able to ramp down much quicker than the producing community. So we were awash in crude oil. And so what we did, well, first we asked Congress for $3 billion to buy oil, but they didn't give that money to us. So we opened up the SPRO and we said, if you want to bring your crude in and store it, you can do that. And you leave a little bit behind as a rental payment, if you will. And so what has emerged in the last 8 months with the Strategic Petroleum Reserve, it now has a new mission. Before, the mission was, if we had a hurricane in the Gulf, we'd move oil to the refineries because the platforms, the offshore platforms, were shut down, and we can still do that. But now, if we have another pandemic or some other reason why we might have tremendous demand destruction, we can bring that crude oil in and store it. So that's the complement of work that we do, but the majority of our funding, the majority of your taxpayer dollars, goes to R&D. And the final thing I'll say on R&D is that the work that we do comes out of our National Energy Technology Lab, which is just south of here. We've got a lab in South Park. We've got a lab in Morgantown, West Virginia, and we have a lab in Albany, Oregon, and that makes up the National Energy Technology Lab. And I've told people this, and it is absolutely true. They are the foundation upon which all of our fossil energy research gets done. And it's a hidden treasure that you have in this region, and they just do phenomenal work. So, long answer to a short question.
Very good. First of all, I should have probably set the stage a little bit. We're going to be open to questions. Lauren's going to assist us in kind of handing off questions to Steve as the program goes on. But I thought it might not be a bad idea to provide a little background. Steve started his discussion about LNG export and the capacity to move natural gas. Anybody have an idea how much natural gas was produced in Pennsylvania, for instance, in 2008? Anybody? We produced about 180 BCF a year in Pennsylvania, a billion cubic feet. That was about a quarter of Pennsylvania's demand. Today in this basin, we're producing 11.7 trillion cubic feet, 6.8 trillion out of Pennsylvania alone. Pennsylvania alone is 20% of the U.S. demand. We're meeting 33% of the U.S. demand out of Ohio, West Virginia, and Pennsylvania out of this basin. That's enormous when you think about producing products. Not only heating your home, cooking your food, drying your clothes, heating your water, but all steel, glass, plastics, chemicals, fertilizers, powdered metals, pharmaceutical medications. And today in Pennsylvania, 1 in 4 electrons, about one in 3 across the country. So a pretty big deal in what's happened here. I know certainly we've had a lot of discussion around energy policy in this country. Steve, I'd like to ask the next question is the issue of on all energy policy discussion underway within DOE, and from at least from a generation standpoint, what's your thoughts on natural gas versus coal versus nuclear versus renewables? Is it an all energy strategy to meet the nation's demand for electricity?
Yeah, clearly in DOE, it is an all of the above strategy, and we're working across all forms of energy from renewable to natural gas to coal, improving the ability to move these energy sources around. We cover the whole spectrum. I think that notwithstanding concerns about climate change and what I call a good deal of hand waving that we're going to be 100% renewable by 2030. Again, not too good in math, but I think that's 10 years unless they give us to the end of 2030, and then it'll be 11 years. And so we're going to transition the entire economy in a 10 or 11 year period. Anyone that understands the infrastructure around the United States knows that can't happen. But what can happen is we can continue developing the technologies across the energy space to make coal, oil, and natural gas near zero emissions. That can be done, and that's a lot of what my office is focused on. We're also focused on improving, we call it storage rather than batteries, but battery life, and we're focused on hydrogen. We'll get into some hydrogen a little bit later, I think. But I believe that this is natural gas time to shine, because it is just a solid partner for intermittent renewables. California is probably the poster child right now for what can happen if you go headlong into renewable and you don't back it up with something with a reliable supply of energy. Then what happens? You have rolling blackouts. Why did California have rolling blackouts? You didn't ask me this question, but I want to talk.
I was coming there. I promise you.
Why did that happen? It happened because they have a lot of wind and solar, but the wind and the sun didn't show up on some of the hottest weather they had. Where were they getting the power when the wind wasn't blowing and the sun wasn't shining? They were getting it from states to the east of them, and it was mostly natural gas. But those states were also experiencing hot weather, and so they weren't able to supply California with power, and that's why they had the rolling blackouts. What some more rational minds in California are suggesting is we've got baseload generation in California. It's called natural gas combined cycle. Let's put carbon capture, utilization, and storage on that baseload generation, and let's take the CO2 and inject it into oil fields near Bakersfield, California. They still produce oil in California. Let's inject it. We can produce more oil with the CO2, and the CO2 will stay sequestered in the ground, stored in the ground permanently. Now that starts to make some sense, because now they can produce near zero CO2 power, and it's base load power, and it can ramp up and it can ramp down. So when the wind quits blowing and the sun quits shining, they've got reliable power. And again, some more rational minds are talking about that. We'll see what happens. But it just shows you that if you don't have this base load power, some very bad things can happen.
So we're talking about that power experience, Steve. I'm going to talk a little bit about unconventional natural gas development in a minute, give you a chance to talk about some of the research going on the unconventional natural gas development side. But before I do that, I think about the going from a period of scarcity and high price for energy in Pennsylvania, both electricity and gas, primarily in gas, just a little more than a decade ago, to now a period of abundance and affordability. Gas prices have dropped at every utility in the state anywhere from 56% to 76%, depending on which utility. If you're here in Western Pennsylvania, Peoples, which bought Equitable, it's about a 73% savings on the commodity prices of what they were in 2008. Extraordinary savings to consumers. But what was the impact of having to buy power on the open market in California to ratepayers' bills? Because I'll tell you, natural gas affordability in Pennsylvania has driven down wholesale electric prices by 40%. What happened in California this summer on the price side?
Actually, you ask a question I don't know the answer to.
Okay.
I would guess it went way north of $100 a megawatt hour, but I don't know. And it has in the past gone to $300 or $400 a megawatt hour, and sometimes even higher.
Okay.
So I am quite certain that power ramped up. What I can tell you is California came to DOE and we did what they call a 202C, which is emergency authorization for the state of California to run everything that they could possibly run in order to avoid the rolling blackouts. So the 202C essentially gives them a waiver on emissions.
Okay.
And so that's how they dealt with the problem, but they were only able to partially deal with it.
Okay.
They just simply had to work through the hot weather period they were in because they had a big shortage in that part of the country of baseload generation, coal and natural gas, because the other states that had those sources of supply kept them.
Yeah. So I look around the room and I see a lot of familiar faces here, folks that are active in our committees. One of the things that really makes the MSC strong is we're able to listen to folks that are doing work in the field. I know that you have folks on the virtual discussion today from West Virginia and other parts of the shale play that have been absolutely critical to that debate and that discussion. There's research that goes on broadly across our spectrum to kind of high grade rules and to make sure we're performing at a high compliance rate. One of the things that we look for is research partnerships, and I think DOE is a prime example of a wonderful research partner. And Steve, I mean, the big change in natural gas development, we've got a long history in Pennsylvania drilling for natural gas wells, but the real change has been the ability to turn a drill bit horizontal. It's not been hydraulic fracturing. It's being able to turn a drill bit horizontally to produce far more acreage off of a single well location than ever thought possible before. So when you take a look at the unconventional business, there are still questions to be raised. What's some of the research that DOE has undertaken to take a look at the unconventional side to promote optimum conditions for production?
Yeah, a great question. And let me just take you back in time a little bit. I'm looking around the room here, and some of you were paying income tax in 1990. And so in that 1990 timeframe, we used $140 million of your taxpayer dollars. Some of you weren't, but your parents were. And we took that $140 million and we did two things. One, we developed directional drilling. And number two, we developed fracking. And the amazing story here that is not told very often is private industry, a guy by the name of George Mitchell in Texas, picked up that technology that we developed. And out of that has now come hundreds of billions of dollars of enterprise here in the United States. And again, making us the largest oil and natural gas producer in the world. So that's what we did back in the 1990s. What you should be asking is, what are you doing for me today? And what are you doing for me tomorrow? So let me tell you, we're putting about $60 million right now into production. One piece of that is understanding the subsurface. We call it being able to see in the subsurface. Now, how do we do that? We get data from producers. We also have 17 field sites where we're doing unconventional oil and gas development, and we're pulling data from that. And then we're using our artificial intelligence and our machine learning and our high performance computing, some people call it supercomputers, to take that data, cull through it, digest it, understand what's happening subsurface. So we get data from core samples, we get data from drilling, we get data from completions, and then we get production data, and we can start to see what's happening subsurface. And the reason that's important is because you might have a 2 or 3 mile long lateral, and from frac stage to frac stage to frac stage, there's tremendous variability in production of both oil and natural gas. Why is that? We don't really know. A lot of the producers think they've got the secret recipe, but they don't, because there is that variability through the same shale. If we can understand that and we can figure out what's changing, and maybe it's proppant, maybe it's pressures, maybe it's the type of fluid, but if we can take all of that data in and begin to understand this, my oil and gas experts, my subject matter experts, think that within the next 10 years we could double production from a well, taking it from about 10% of the reservoir to 20%. If we got there, if we even got half of that, it would be game changing. It would be almost as game changing as the shale revolution. So we would be producing more oil and natural gas from the same well, less wells, lower cost. So that's one of the areas that we're focused on. We're also looking at things like corrosion. There's corrosion subsurface. We're looking at things like microbial activity. There are microbes down there, and what happens when they're exposed to water, what happens when they're exposed to air. And sometimes those microbes can be helpful, sometimes they can be harmful. And so we're understanding that. So scaling, microbial activity. Another area that we're focused on is methane reductions. And we've got about $25 million that we're spending, and that's across the value stream. So from production to transportation in the pipeline, storage, compression, all of that, we're focused on methane reduction because A, it's a greenhouse gas and we need to reduce it, and B, it's much better sending it to a burner tip rather than emitting it into the air. It makes good economic sense. So those are the two big areas that we're focused on in the oil and gas space.
So I'll come back to the issue of LNG exports, Steve, because there are probably some folks in the room saying, why are we doing that? Still have 3 billion people across this planet that live in energy poverty. How many of you have been out of electricity for 3 or 4 days? We get pretty uncomfortable when we have our power curtailed, but there are people across this planet, and lots of them, that live without the availability of electricity, 24/7 like we have. I think back in my days and spent some time working with the Department of Energy in Washington in 1986, 7, and 8, and at that point we were plus 50% dependent on foreign oil. Just a few years ago, we were 60% dependent on foreign sources of oil. Our newfound abundance of energy, made possible by unconventional development of both oil and natural gas, has been a game changer. Are you concerned that we outdrive our headlights in terms of sending more of our products overseas than we can sustain long term? What's your thoughts on that?
Great question, and I get asked that question a lot. And here's the beauty. This is private capital and it's market-based. So there's competition for LNG. Qatar, Australia, Russia provide LNG, so we compete against those mostly state-owned entities. So we're competing against them. So if the price of natural gas starts to go up, I don't know where the break point is, but let's just say $4 or $5, then we might be $7 or $8 getting that LNG to Rotterdam.
Yeah.
Well, now we're not going to be able to compete because Qatar's a little bit closer, Russia's a lot closer, and they can bring natural gas in by pipeline. So I think it's self-levelizing. If natural gas prices in the United States go up, we're not going to be as competitive, and so the exports will go down.
Yeah.
And I really do think that the market will take over because, again, this is private capital that's building out these LNG export facilities. Now they're getting more efficient, so that means we're getting more competitive. One of the things about our LNG exports is we have some of the most flexible contracts in the world because it's private capital. So if somebody wants to buy LNG from the United States, they can come in and they can purchase their gas, they can pipe it to the LNG facility, they can have what we call a tolling service. LNG will cool the gas and put it on a ship, and then that buyer can lease the ship and send it to wherever they want it. They can also do a turnkey service where they say, I want LNG delivered here, you take care of it. And the LNG exporter will do that. And then there's everything in between. You can take an equity position in an LNG facility. You can take an equity position in a production site. And so we have a lot of contracting flexibility that some of the state-owned entities that are selling LNG to Europe and to Asia don't have. Some of them tie it to the price of oil. We don't, because it's private industry. And so that really gives us an enormous amount of flexibility. The final thing, some of our competition has what they call destination clauses. It says, I'm going to buy LNG from Qatar and I want it delivered to Rotterdam. Well, if the buyer of that gas or that LNG says, I don't need it in Rotterdam, I want to move it to Poland, Qatar may not let them do that because they have a destination clause. A US company says, okay, you can move that gas anywhere that's not prohibited by US law. And we do have, they can't move it to Iran, for example, but otherwise they can move it anywhere in the world they want. Again, tremendous flexibility if you're a buyer.
Move it anywhere in the world except a U.S. port, because we don't have under the Jones Act. You have to have a U.S. flag vessel to deliver LNG to a U.S. port, and we don't have a lot of U.S. vessels in place. And it's
zero.
any. So that's a big deal. And we had a previous session today where a question was raised about, are you concerned, and what's the Department of Energy doing about, I would call it, blockades to keep natural gas pipelines from being developed into critical or constrained markets. The Northeast, for instance, I mentioned a moment ago that we're delivering natural gas to nearly every single utility customer in the state at or under $5. Last winter during polar vortex in the Northeast, they had prices on an MMBTU basis exceeding $75 in that basin because of the lack of infrastructure. The East Coast market's constrained. So I guess the question, Steve, is one, how are you guys addressing the blockade of pipelines? And two, do you see a future where LNG could be moved off of a U.S. port and delivered to a U.S. port where it's constrained from a market perspective?
Yeah, great question. So at the DOE, especially in my area, we don't get into the policy discussions on pipelines moving through New York State to serve New England. Much needed activity, but that's a policy discussion that takes place outside of DOE. Our role here, because we all know that it is increasingly difficult to build a pipeline in the United States, and I don't care if it's oil, natural gas, CO2, maybe water is still relatively easy, but the rest of the pipelines there's a lot of opposition to it. So one of the things that we can do to help is to develop pipelines that are well monitored and self-healing, and that's what we're working on. Monitored pipelines, so along the length of the pipe, we know the condition of that pipeline. And if there's an area that's maybe getting a little thin or there's some corrosion or some other issue there, we're developing technology where we can run a coating down that pipeline that will adhere to the inside of the wall, and it'll be we call it self-healing. It's maybe a bit of an exaggeration, but in effect, that's what we're doing. We'll be able to fix the pipeline inside, in effect, line it with a liquid. So that's our job, to create pipeline technology where we're monitoring its health and its condition 24/7, so that people's concern over pipeline ruptures can be greatly reduced. The policy issue is a much bigger argument, a much bigger discussion that will continue. It will never end, but it will continue. On your question on LNG, we are looking at small scale LNG. I'm not sure we will get LNG from Cove Point up to Boston because that would require a US LNG flagship. But down in the Gulf of Mexico, there are islands in the Caribbean that are still using diesel oil, or some case number 6 oil, for heating. We're looking at what we call ISO containers, the ability to put small amounts of LNG on ships, small ships, and move it to those island nations so that they're no longer burning diesel. And so we put a small scale rule into place to allow authorizations to happen much more quickly, because the way government works, as you all know, it takes forever and a day to get anything done. And we wanted to be able to authorize small scale movements so that the commercial marketplace could address that very real need in those island nations where some of us used to go on vacation, but we don't anymore, but hopefully we will in the future. And you might be then taking a shower with hot water that's been heated up by LNG instead of diesel oil. The other thing that we've done, I mentioned a couple times, this is private capital. If you're going to make several $billion-dollar investment in an LNG export facility, you need to get a return on that investment. We all understand that. So we just released what we call the 2050 rule, which means that LNG exporters now have until 2050 where they've got authorization to export LNG, because before it was 2030, which doesn't give them enough time to get a return on investment. Now they can go out to 2050. And we just issued that, and we've had now several companies come in and ask for that 2050 authorization. We've authorized 3 companies and more to come, because companies need to have an opportunity to get a return on investment, and the way we're structured before really didn't make much business sense.
So just for folks' knowledge, natural gas isn't produced as a LNG product.
Sorry.
It actually, we bring those into facilities and you cryogenically drop the temperatures. I think I have the right Thane family here, down to 262 degrees below zero to form a liquid, loaded on ships, moved to market. I'm gonna move on to another subject matter, Stephen. One that those of you that are on this video town hall from the Gulf Coast states would understand this completely, is that you have a mature petrochemical industry. We have a new petrochemical industry beginning to take hold here in the Appalachian Basin as a result of liquids development. I call it west of Interstate 79. The shales are under pressure. They deliver liquid hydrocarbons like ethane, pentane, butane, isobutane, propane, natural gasolines. It's not a heavy oil concentration, but those liquids are primary feedstocks for different manufacturing processes. The biggie that's developed just about 25 miles to our west is a petrochemical hub that's being matured now by Royal Dutch Shell that'll take ethane and steam ionize ethane to form ethylene, and secondarily take ethylene to form polyethylene. Forms what they call PE, or plastic pellet, that'll be used in manufacturing. So that's the next part of this conversation that I'd like to take it, Steve, is that we have an emerging plastics industry and petrochemical industry in this basin. We've seen some modernization and some investment going into the Philadelphia region with Marcus Hook, but now a plus $7 billion investment here to our west, with almost 8,000 of our building tradesmen and women working at that site, 600 permanent jobs. I would say that this is the next generation of manufacturing they have available to us. We can do that work in China, or we can do that work here. What are your thoughts on what's happening there? And then I'd like you also to comment on the plastic products that are going to be produced as a result of that work, producing it here versus producing it somewhere else.
Well, yeah, let's start off with this region. The Shell cracker, there's enough ethane that can be produced in this region to support 4 more equally sized crackers. So if you start thinking about 5 of these crackers in this region, you're talking about 100,000 full-time, family-sustaining generational jobs. And then there's all the downstream that can come with it. So they produce those pellets, those plastic pellets, then that can serve polyethylene pellets. those can then go into a wide variety of plastics products that we all use. And you're right, we could ship the ethane over to China and they could produce these plastic products for us and then ship them back. But they're not going to produce them with the same low environmental footprint than Shell will. This is a state-of-the-art cracker. And the next 4, if we're lucky enough, will also be state-of-the-art crackers. The most efficient, the most low-emitting crackers in the world will be can be built in this region if this region wants that to happen. And there's, of course, a price difference there, right? 70% of the plastics production happens within about a day's drive from Pittsburgh. So you think about it, we've got a petrochemical industry down the Gulf of Mexico. We got Shell up here. We could pipe the ethane down to the Gulf of Mexico, produce the pellets and bring them back up here. But what Shell can do now is have almost just-in-time delivery. Rather than waiting a week for your raw material to make the plastic, they can ship it overnight. And so there's a cost savings there. By some estimates, about 25% cost savings. And again, it will be the most efficient polyethylene production in the world. And then finally, we're diversifying this much needed industry, because if a hurricane rolls up through the Houston Ship Channel, a lot of that gets taken out. We've seen a number of hurricanes already this year, and it's pretty devastating to those areas. They have to shut down manufacturing. That doesn't happen up here. So there's a whole lot of reasons to do this. Now, I fully understand that plastics gets a bad rap. You know, we all see the bottle strewn beaches and that sort of thing. But the reality is, when you're staring at your computer, that's plastic. Parts of these tables are plastic. That water bottle's plastic. You get in your car, you're cocooned in plastic. If we ever get on airplanes again, you're cocooned in plastic. You go into a intensive care unit, it's life-saving plastic that's surrounding you. We're not going to get rid of that anytime soon. So let's make it as efficiently and cleanly as we can. And then what the department, well, Secretary Perry used to call it the Department of Everything. Now he was being it's a little bit of a joke, but it is kind of the Department of Everything, because one of the things that we're tasked with doing is looking at what we do with waste plastics. We can recycle some of it, but we can't recycle all of it. And so what do we do with that portion of the plastic we can't recycle? And one of the things that we can do is we can gasify it with coal, with biomass, and we can produce hydrogen. And hydrogen used in the transportation sector or for power generation or in the industrial sector is zero emitting hydrogen then. When we combine coal, biomass, plastics with carbon capture, utilization, and storage, it's zero emitting hydrogen. And I think, you know, every 20 years or so, the United States starts talking about a hydrogen economy. I think this time it might take hold. And so the Department of Energy is focused like a laser beam on the entire hydrogen value stream, from production to how we transport it to how we use it.
Where's it come from, Steve?
The
Where
hydrogen,
are you going to get the hydrogen from?
Great question. About 95% of the hydrogen produced globally comes from natural gas, but it doesn't have carbon capture, utilization, storage. It's a process called steam methane reforming, and that's where the bulk of it comes from. So therein lies a great opportunity for the abundant natural gas we have in the country to produce hydrogen. And with CCUS, it'll be virtually emission-free. As I mentioned, we can also do it with coal. If we put some biomass and this waste plastics in, we can produce hydrogen not with near zero emission, not with zero emission, but with net negative emissions, because the biomass component with CCUS makes that gasification system net negative CO2 emissions. And here's the other piece of it. How many have heard about the green hydrogen? Oh, I got an hour more. I got to talk now. Europe, Google it. Europe has color-coded hydrogen. There's green hydrogen, there's turquoise hydrogen, there's blue hydrogen, and then there's gray hydrogen. Green hydrogen is using electrolysis, so basically distilled water, purified water, and you zap it with electricity. Water is H2 and O. You separate the hydrogen, the H2 from the oxygen, and you produce hydrogen by electrolysis. It's a well-known process, can be done. The problem is, if we're going to use hydrogen in the transportation sector, you have to compare it to oil. And electrolysis is the equivalent of about $250 a barrel oil. We're currently sitting at about $40 a barrel. It'll get back up to 60, but that's a big price spread. My question to you is, are you willing to give up your gasoline car and go to a hydrogen vehicle if you're going to pay the equivalent of $250 a barrel? I think not. With natural gas and CCUS, we can produce it at about $80 a barrel. With coal, biomass, and waste, plastic, we can produce it for about $70 a barrel. That's at least within the ballpark of current oil prices. So that's how we're going to produce it. But it also means that we're going to need to rethink our infrastructure and how we move energy. And so perhaps therein lies an opportunity for your company. We've got a natural gas pipeline infrastructure around this country. We could put anywhere from 15 to 30% hydrogen in that natural gas infrastructure. We could produce it, put it in the natural gas system, and move it to where the demand is. Then we separate the natural gas from the hydrogen. Natural gas goes to its market, hydrogen goes to its market. And what that will do is give us a jump start into the hydrogen economy, because it's going to be very challenging to have a hydrogen economy if we have to build pipelines that are 100% hydrogen capable. So I'm pretty optimistic about it, as you probably can tell.
Steve, I've heard you and the secretary both speak of energy being interconnected and plastics being interconnected, natural gas being interconnected with movements in our society. For instance, we all watch television today and you see where Amazon's going to buy thousands of new delivery vehicles. And you talked about getting on a plane or getting on a bus, getting on a ship, you're wrapped in plastic. Mm-hmm. I'd be interested to hear what you have to say about new electric vehicle market and how existing sources of energy are interrelated with being able to move more towards the electric vehicle market.
Okay, yeah, great question. So I think it's possible that in the passenger vehicle market in the next 30 to 40 years, a lot of it might be EVs, electric vehicles. So you'll drive your electric vehicle and you'll go home and you'll plug it in to your outlet. And or if you haven't driven it very far and you have battery capacity, you might turn it around and that battery might end up powering your home while you're cooking your dinner and you're watching TV and your microwave's going, and then everyone goes to bed and it goes the reverse direction and recharges your electric vehicle. I can see that happening, but that means we're going to need a lot more electricity coming into everyone's home. And I'm pretty sure that at nighttime, we're not going to get that from solar panels. The wind doesn't blow much in the evening. It does more in the morning and in the afternoon because of the temperature changes. So all of this has to be interconnected, and we spend a lot of time looking at an integrated energy system because different states are going to transition towards renewable at different rates. California, New York probably transition faster than Pennsylvania, for example. But it's all interconnected. Pennsylvania is connected with New York. Pennsylvania is connected with New Jersey. And so it's our responsibility at the DOE to look at our electric distribution grid, how we're going to generate power, how we're going to get it on the grid, how it's going to be consumed, and it all has to be integrated. And the point that I've made to people is going to 100% renewable might be a noble pursuit, but it's not practical. So let's look at what we can do with existing infrastructure, existing power generation, and how do we make it virtually zero emitting. And I think we have the technology coming along very quickly that will allow us to do that, because it is all integrated together, and you just can't isolate anything. I don't know if that answers your question.
It does. I guess the follow-up, and I'm gonna make a little plug here for Pennsylvania produced natural gas produced in West Virginia and Ohio. Is today we're producing about 40% of the power in PJM with natural gas. We've had a 90% drop in sulfur dioxide emissions, a 80% drop in nitrogen oxide emissions, total VOC emission drop, and about a 30% drop in CO2. CO2 across the country has dropped 9.7% over the last 15 years. Not in spite of natural gas, but because of natural gas use. So that's my selfish plug. I'll ask the question, Steve. We were talking about electric vehicles by volume. A van, for instance, that Amazon may buy. How much plastic is in that vehicle? And I guess I would ask, where do the electrons come from? And are you concerned about? And maybe this is outside of your shop's work, but are you concerned on where the technology goes and the need for rare earth metals for developing batteries? Where does that come from?
So in your average automobile, about 50% by volume of your automobile is plastics, and that correlates to about 10% by weight. And so what that has allowed us to do is really decrease the weight of automobiles, which then make them more efficient, get higher mileage. And there's more work to be done there, by the way, but I think the U.S. has made some pretty good progress in that area. But David brings up a very good point. What we don't talk about is, if we're going to do this energy transition, where is the material going to come from to do the transition? And let me give you one factoid. Tesla batteries are about 1,200 pounds. So a 1,000-pound Tesla battery, I'm going to use 1,000 pound because it's a round number. In order to make that battery, to get the cobalt, the lithium, and the copper to make that battery, you have to move about 500,000 pounds of dirt to mine those materials. So 500,000 pounds of mining activity to create a 1,000 pound battery. Where are we getting this material right now? A lot of it is coming from China, and a lot of it's coming from Africa. And to a large degree, China has gone in and bought up these mineral reserves in African countries and provided them with some infrastructure they needed, a highway or a railway or whatever, and in return, they got this material. What COVID has taught us is that supply chain management is really important. And so as we look at this energy transition, where is the cobalt, the lithium, the copper, the silver, where is all of that going to come from? Are we going to be importing that? And by the way, without getting too dramatic here, some of that is done with child labor, literally picking pieces of critical minerals and rare earth elements out of a stream running along a belt. It's happening. So you got that social issue, but then you also have our domestic energy security issue. If we're going to go through this transition, we better know where that material is coming from and make sure that it can't be shut off. And so one of the things that we're doing, we're just, in my office, we're standing up a division of material sustainability. And it's not just going to be fossil energy we're looking at across the energy space, what materials are we going to need? How much of it do we have in the United States on a reserve basis or resource base? What's going to be the cost of producing it? What technologies are needed so that we can produce it at a lower cost, more efficiently? Because right now we're producing precious little of rare earth elements and critical minerals. You know, the stuff that you have in your iPhone and your computer, and that the Department of Defense absolutely needs to maintain our security, those rare earths are coming from China. They have a corner on the market. And the federal government does not think that that is a wise path for us to go down to, especially if we're going to need now orders of magnitude more of this material. So we're beginning to focus on this, and we're doing it across the Department of Energy space. We know we have the minerals here. We know that we can mine them, but we have to be able to process them, and we have to do it cost effectively. And so it's a big issue, but we never talk about that, right? We don't talk about the fact that if you're going to build a solar panel or a windmill, you first need to, or a battery, you first need to go put a shovel in the ground. And no one talks about that, but it's a fact.
Sausage making.
Sausage making, yeah.
Very good. So we have about 10 minutes left. Are there questions in this room? Are there questions for folks that are online? Yes.
You say that the solution requires all forms of energy. Everything has to be interconnected. I definitely agree with that, but I guess my question is, why is it that the DOE doesn't consider those renewable sources as a part of that all incorporation? Like, I know you were bringing up circumstances that, you know,
I'll repeat this.
they brush them off to the side pretty much, like, it's great, but I feel like it's still beneficial to consider them, even though there's going to be days that it's not sunny.
So the question for those that are online and not able to hear what's the question raised in the room, the question was raised, why is Department of Energy not looking at renewable much like it looks like at fossil? And we'll allow Steve to answer that, because I think the answer is pretty clear in what that you are looking at that, but go ahead, Steve.
Yeah, if I gave you the impression that we're not actively working on renewable energy, I gave you the completely wrong impression. In fact, we have an energy efficiency renewable energy office that is dedicated to renewable energy. So solar and wind, batteries. In the hydrogen space, they are also responsible for hydrogen in the transportation sector. That office is also very active in plastics recycling. So a huge amount of work. In fact, their budget is about 4 times what my budget is. So if I gave you that impression, that's my bad. I apologize. We're very active in that, as we are in nuclear energy. We haven't talked about it, but small modular reactors, in effect, walk-away reactors, and that is a very big effort that we have underway. And we have it underway for 2 reasons. One, nuclear reactors don't emit any CO2 at all, have 0 emissions. What we need is small modular reactors, because the big reactors that we built in the 60s and 70s, where we'd have 1,800 or 2,000 megawatts, with distributed renewables, we need smaller distributed generation to back up those renewables. So we've got renewables, we've got small modular reactors, we have small coal-fired boilers. We're working on 100% hydrogen capable turbines. So across the board, we're focused on all energy, as well as the transmission and the distribution of that energy.
Steve, are you concerned about scale? There's some will say we got to tomorrow shut fossil energy down and go immediately to all renewables. I mean, the fact that we've doubled the use of renewables is a valid point, but we've doubled from 2 to 4% or 2.5% to 5%. Are you worried about scale? And is it real to think we can jump that quickly into a 100% renewable market?
Yeah, you're correct. It's not real to think that we can do that. I mean, just look at the energy infrastructure that we have in this country, and to every one of those cars out there in the parking lot or on that highway, and the trucks have to quit using diesel or gasoline, and all that has to happen in the next 10 years. How does that happen? In order to get rid of coal, nuclear, and natural gas power generation, and it's all renewable in the next 10 years, at the growth rate, and the growth rate of renewables has been quite high, but we're only a couple of percent. So that is a Herculean lift. So I don't think it can happen in 10 years. Also, people that talk about that, I think of them as sort of hand waving. They don't really understand the energy infrastructure, how long it took to build out and how long it's going to take to go through this energy transition. We'll watch what happens in Europe. I would point out to you that Germany's electricity prices are about 5 times what they are in the United States. So we can see some of what Europe is doing, and some of those countries are in a headlong rush, and we'll learn a lot from them. We'll learn what to do and what not to do. We'll get through some type of energy transition. I don't know how fast, but we've been evolving in how we make energy since the dawn of the country, the dawn of the civilized world, and we'll continue to evolve. How quick? We'll see.
Lauren, you have a question?
You have a question here. Hopefully they can hear it, but is the Department of Energy looking at the possibility or feasibility of extracting rare earth metals from coal ash?
Question was, is Department of Energy looking for rare earth metals development from coal ash?
I'm gonna need another hour. The short answer is yes. We've got a pretty robust program in that area. So we're looking at rare earth elements from coal, and also for you that have been in mines, there's the ceiling and the floor, and there's clays, and it turns out that in the ceiling there tends to be higher concentrations of rare earth elements than in the coal. So when you got a long wall moving through, we can extract the rare earth elements out of that higher concentration part of the upper part of the coal seam. We're also looking at coal combustion byproducts, because if you think about it, rare earth elements aren't really rare. They're all over the place. They're just in very small concentrations. So if you burn coal or you gasify coal, you are in effect concentrating the rare earths in the combustion byproduct. And we're having great success in extracting that. The other area that will be of interest to folks in this room is we are also extracting rare earths out of acid mine drainage, which right now abandoned mines are a state problem. That means that your state tax dollars are paying for that. It is a liability. We all seen it, the kind of orangish water flowing down a hill. What if we can extract rare earths out of acid mine drainage and turn that from a liability into an asset, and extract those rare earth elements and put them into our economy? That would be huge. And so the longer answer is we are working on it across that space, and we're making good progress. In fact, West Virginia University has a pilot plant extracting rare earths from acid mine drainage.
I feel like there's a lot of questions.
Okay, well, that's good.
Bring them on.
Okay,
Wonderful.
let's see. Where does hydroelectric fall in your department's R&D efforts?
That comes out of our...
Want me to repeat it so folks can hear?
sorry.
The question was, where does hydroelectricity fall in the R&D efforts within the Department of Energy?
Yeah, and that comes out of EERE, the Energy Efficiency Renewable Energy Office. Hydropower is a bit of a challenge, because if you think building a pipeline is difficult, try getting a permit to build a dam. But what can we do there? We have dams that were built back in the 40s and 50s, and we can repower those with higher efficiency hydro turbines. And so as they age out, there will be opportunities to do that. We also look at, there's low head hydrogen. So along, which way is the Ohio River? I'm turned around here. Along that way. Yeah. Along the Ohio River, in our locks and dams, there may be opportunities there because it's low head. It's might be 10 or 12 feet. It's expensive, so it's not commercially viable right now. But we're looking at some of the technologies where we could put low head hydro into locations like that where you've got a little bit of a vertical drop.
Okay. Do you have any feel for the amount of waste that might be generated from the extraction of hydrogen from plastics?
The question was the amount of waste that's generated from extracting hydrogen from our plastic waste stream.
Great question. We would not gasify, at least I never say never, it's unlikely we would gasify 100% plastics for hydrogen production. Rather, it would be a smaller portion of the feedstock. The main feedstock would be coal and biomass, and then we would add the waste plastics in. What happens when you gasify, especially in an oxygen atmosphere, they call it an oxygen-blown gasifier, that what comes out is almost like a glass-like material. So the residual coming out of the gasifier is a hard glass-like material which can easily be landfilled. You're not going to get leaching out of that. It's not like burning coal where there's a potential for leaching in the coal combustion byproducts. That won't be the case with oxygen-blown gasifiers, and that's the type of gasifier you would use to make hydrogen. Very knowledgeable question, by the way.
I'm not sure if this, if you could answer this, or if you're looking into this, but give it any feel for what sections of the population would maybe be put most at risk with a premature transition to green energy.
So what sections of the population will be placed at greater risk as we transition towards a more green energy platform?
And I think the answer is, what's the cost? Because the lower income people in the United States pay a far higher percentage of their disposable income for energy. I would hazard a guess that around this room, you're spending anywhere from $4,000 to $6,000 a year for all of your energy. It's gasoline and home heating and all of that type of thing. Well, if you're making $14,000 a year and you're paying $4,000 and it's going to go up to $6,000, that's significant. And so I think the answer is it depends on how much it costs us to go through this energy transition. David was talking about the value of natural gas. For a family of 4, because of lower natural gas prices to the home as well as lower electric prices due to low natural gas prices, it's about $2,500 for a family of 4. That's been the savings over the last several years. I don't know about you, but that's pretty significant for me, and I make not in the government, I don't make a reasonably good income, but it's okay. But what if you're making $14,000 a year and you now have $2,500 savings? That's big. So I think that's how I view it. How much is it going to cost?
Gentleman over here. Yes.
I have a question. So there's approximately 7 countries in the world that are either at 100% renewable energy or close to that. 4 of which are third world countries, and 3 of which are third world countries, including Paraguay, Costa Rica, Brazil, and 4 of them are not first world countries. So, for example, Iceland probably took around 50 years to move to 100% renewable energy. Brazil uses 75% renewable energy, and it's a country that's approximately 11% bigger than the United States. I don't know what the cost of electricity will be in Brazil. I don't have that information. But my real question is, like, I think it will be very hard to move to renewable energy, in my personal opinion, based on the infrastructure that we have right now in this country, as we discussed. But has any of those models been looked upon? And are we striving to go in that direction? Or are we more striving to improve the process of non-renewable energy so we can have either close to zero emissions, or what's the direction that the department is going into? More going to 100% renewable, or more going into researching to improve the non-renewable energy? Both.
We're doing both. I'm sorry.
That's a tough one to repeat, but the question is that there's a belief that there are a number of countries in the world that are close to full renewable capability for their generation capacity. And is the Department of Energy looking closely at those countries? And do those models at all pertain to the U.S. and movement towards more of a renewable environment?
Yeah, and the answer is we do both. We have to. Given our current infrastructure, we have to be all of the above. That means we have to continue to work on renewable energy, making it lower cost, and battery storage capacity to make it more reliable so it's less intermittent. But we also have existing infrastructure that's not fully depreciated yet. And when you shut down a piece of infrastructure that's not fully depreciated, there's a cost associated with that. And so we need to be looking at those pieces of our infrastructure that still have a long life, and how do we reduce the emissions from those, make them more efficient. So it really, it has to be an all of the above strategy. Now, depending on administrations, it tilts one way or the other, but I can tell you that at the Department of Energy, we have maintained a focus on all of the above, and it really hasn't tilted much. And in fact, it doesn't tilt much, a whole lot. It does from a policy standpoint, but not from a budget standpoint, because at the end of the day, Congress appropriates the money, and Congress, to a large degree, tells us where we're going to spend that money. So they appropriate money for renewables, they appropriate money for nuclear, for fossil, for cybersecurity. We haven't talked about that. So they appropriate our money and tell us pretty much where we're going to spend it. And that really hasn't changed a whole lot, although my budget has increased a little bit, and that's been valuable because we need to focus on things like carbon capture and hydrogen and so forth. Yep. Let her roll.
Well, how about we do 10 more minutes? We'll do 10 more minutes. There's a young lady in the back that has a question.
We got one over there.
Okay.
Oh.
What's the one or two technologies that you're most excited about when it comes to carbon capture? And have you seen a lot of improvement over the past 10 years?
So the question is, in the department's study of carbon capture sequestration, what are the couple of technologies that the department's so excited about, and what's the focus over the next 10 years, do you believe?
Okay. I paid him to ask that question. So that's a joke.
Yeah.
Yeah. You'll get your money later. Trust me. I'm for the federal government. Yeah. So we are working on advanced amines and membrane technologies. Membrane technologies hold a lot of promise, but we're not quite there where we need to be able to separate the CO2 out through membranes. But the advanced amines are looking pretty good. And to your question on the cost, when I came to DOE, let me back up. About 75% of the cost of CCUS is tied up in capturing that CO2 molecule. And then the balance is piping it, compressing it, and injecting it. So I said, let's focus on where the big cost is, and that's capturing it. 3 years ago, we were at about $60 a ton capture cost. We're now down to about $45 a ton, and we are well on our way to get it down to $30 a ton for capture costs. So we're going to cut the cost of capture in half. And the reason that that's important is because we have this thing called 45Q. Congress passed or updated a law that gives, if you store a ton of carbon for enhanced oil recovery, you get $35 a ton. If you store it in a deep saline formation, you get $50 a ton. So if you can capture CO2 for 30 and you can get a $35 a ton tax credit, the beauty of that is that industry will pick that up because they can make a business out of it. They can make money on it. And I keep telling people, when that happens and private industry picks this technology up, the federal government can back away because that's when the learning will really begin.
As we transition away from coal in power generation, a lot of the coal-fired generators, and like specifically around here along the Monongahela River that I see regularly when I drive by, have been forced to retire plants. And because it's so expensive to reclaim that property and repurpose that property and that infrastructure, a lot of those generators haven't done anything with it. So it's just sitting there deteriorating, becoming a real eyesore on some of like nice riverfront property around here specifically. So I was just wondering if there is any federal funding available to coal-fired generators to repurpose and reclaim those pieces of property to be used in maybe converting to natural gas generation or some other generation of the future?
Okay, I'll try to repeat that. That's a long question, but I'll do my best. There have been a number of coal plants that have been retired, especially along the Mon River Basin, that have not been reclaimed. Is there money available or encouragement by the government available to electric generators to repurpose or reclaim those properties? Second, are there opportunities for those plants to be retrofitted to basically operate on natural gas? Am I close?
Yeah.
Very good, thank you. I'll take the first part of that, Steve. There have been $13 billion of investments here in Pennsylvania to build either greenfield sites to basically generate power, with natural gas, or retrofit sites. I think there are 7 retrofitted sites in PA right now where they basically retrofitted coal-fired facilities to burn natural gas. Again, $13 billion of investments, and that's been a winner for Pennsylvania. We've improved air quality. We've put building trades to work, and we're generating power. About a 40% savings in wholesale power generation costs have been reduced as a result of that. I'll let you answer the second part of that is reclamation and things like that.
I'd add on to what you said. The PTT plant that they're thinking about or working towards building on the shores of the Ohio River in Ohio was a coal-fired power plant. It was the Berger Power Station owned by First Energy. That plant was raised. The facility or the site has been cleaned up, and that's where the PTT plant will go if they reach final investment decision. So there are opportunities to repurpose those waterfront sites because they're very valuable. They may be valuable for building condos, but they may also be valuable because they're deep water ports and it's industrial applications or commercial applications. What we're doing at the Department of Energy is we're designing and developing the 21st century coal plant, which is again going to be similar to nuclear reactors. There'll be small modular plants with 0 emissions. And so we just issued $80 million notice for 4 different facilities, one of which is in Greene County, Pennsylvania at Consol Energy's mine down there. And they're going to be building one of the 20, we're just doing the FEED study right now, but they will be hopefully building about a 300 megawatt, 0 emission, very highly efficient coal-fired power plant with carbon capture utilization storage. So there, if we can do that with natural gas plants, we can do it with coal plants to use some of the existing infrastructure at that facility. You might have a turbine that's usable, you might have transformers that are usable, wires, material handling systems. And so to the extent we can go in and repurpose that, take out that 1960s, 70s vintage technology and put in 21st century technology. There are funds available to do that at the Department of Energy. There are also state funds available for that.
Lauren, one more online question?
One more.
We'll call it a day.
With the emphasis on renewables and the fact that we're shutting down older nuclear reactors, maybe some inclusion of SMRs, what is DOE doing about long-term nuclear repositories? And then he goes on to say, we made a policy decision to shut down Yucca Mountain, but DOE recently commissioned studies over the past few years for using alternative sites and methods, i.e. deep wells. What was the result of those studies?
So let me repeat that question. DOE is doing some additional study on low-level radioactive waste storage. I think today many of the nuclear operators store in dry cask storage on many sites. They did put investment into Yucca Mountain, and as a policy decision, they never really moved a lot of low-level radioactive waste in those sites. So I guess the question is, Steve, what's DOE doing on low-level radioactive waste sites, for nuclear power?
Yeah, the big focus was on Yucca. And that was for high-level defense-related waste as well as civil nuclear waste. That's not going to happen, at least not in the near term. So we have this intermediate storage that we're working on, but that's not the ultimate answer, is it? We can't just have intermediate storage. We have to do something. So there's a wide variety of activity looking at reprocessing the waste. That's, I'll be honest, that's a number of years out. We got a long way to go on that. You mentioned the deep borehole project, and I happen to know something about that because when I was at Battelle right before I came to DOE, we were working on a DOE project that was ultimately canceled. But for the engineers and the scientists in this room, the idea is that we would drill ultimately an 18-inch diameter hole about 5,000 kilometers. And the bottom 3,000 kilometers would be into bedrock. And we'd put high-level nuclear waste in stainless steel canisters, lower that down. Now, all we were going to do in the first round was do the characterization of all this, so no nuclear waste, but the characterization. We'd lower the stainless steel canisters down, and then we were going to do something called rock welding. We would pulverize the granite that came out of the well bore that we had drilled. We'd pulverize it, put it back down in around the circumference of the canister and on the top, and put heating elements in there and melt the rock so that the rock would go into the fissures of the well bore and in effect create rock welding. Now, haven't done it, but a little bit in the bench scale. But that was a project that was canceled under the previous administration. It hasn't gained a lot of traction yet. I keep talking about it within DOE, but what that would allow us to do is, at a minimum, take care of the high-level defense-related waste. And if we can do that, and I'm talking about a couple $100 million to get us to the point where we might be able to do that. So it's a Herculean undertaking. We need to address it. There's a variety of ways to address it. And what we need to do is put our American ingenuity and taxpayer dollars behind it to get the issue resolved. And we're not there yet.
A few of your viewers that may be on this this video chat is, from Ohio. Many of you may be aware there's a criminal investigation over a nuclear bailout proposal that passed the legislature in Ohio. That similar proposal was moved in the Pennsylvania legislature a little more than a year ago. I know you were very active in this in 1994, Steve, and I actually testified because I was beside you working these issues in Harrisburg. In 1994, we unbundled the electric business, the generation asset, the wires asset, and the distribution asset, and $9 billion of stranded cost recovery was provided to operators of generation assets. Then the electric industry actually went back into the legislature a year ago, primarily because of the needed retirement of 3 Mile Island. I mean, many of you know that there are 2 units there, one shut down. All the costs are being borne by a single unit, and they haven't made auction for 4 or 5 auctions in a row. They can't compete financially, so that facility is being retired. The electric generation industry in Pennsylvania asked for another nuclear bailout. We testified to let the market work. Don't necessarily provide another subsidy when the ratepayers of Pennsylvania have already paid $9 billion in stranded cost recovery for the generation asset. So MSC, the fact that there is not a generation platform in Pennsylvania, we stepped up. I testified, I think, half a dozen times in Harrisburg a little over a year ago on that issue. I think we've come to the end of our time. Ken and the CEC team, I want to thank you very much for taking time to learn a little bit more about what's going on in the natural gas space, what's going on at Department of Energy. I want to thank the Assistant Secretary for your expertise and for sharing your thoughts, Steve. And I guess lastly, I want to thank the CEC team. I mean, we're never going to be 100% compliant, but boy, we're all striving to get there. And we get there primarily because of the work that you do and you help us do in the trenches throughout Pennsylvania, Ohio, West Virginia, and across our country. So we really appreciate the engagement that you have with our industry, the expertise that each of you bring to the table to help us try and get to where we need to be in terms of compliance. We're at 98% this year with 616 wells drilled last year, over 19,000 inspections in the state. We won't be happy till we get to 100%. We got a long way to go. We need your help to get there. So thanks very much for your engagement with us today and appreciate you being here. Have a great weekend.
May I say something?
Yeah, please.
Thank you. It's been an honor and a privilege to come and talk to you, and I really appreciated the questions. I spent 30 years here in Pittsburgh, raised my kids here. When I finish this gig that I'm in right now, I'll be coming back to Pittsburgh because we still have 2 of the 4 kids here. And the only other thing I want to say to all of you is go Steelers.